the next session on fluid mechanics. In this session, we are going to discuss about some numericals on the topic of viscosity. We have already seen a few numericals. We will see a few more numericals now. Two large plate surfaces are 2.4 centimeter apart. So it's given that there are two surfaces here and the distance between these two plates is 2.4 centimeter. The space between the surfaces is filled with glycerine. So here we have glycerine between these two plates. What force is required to drag a very thin plate of surface area 0.5 meter square? So I'll also write down the data that is given. The area is given as 0.5 meter square between the two large plane surfaces, and it is dragged at a speed of 0.6. So here I know that the speed is 0.6 meter per second. If the thin plate is in the middle of the two plane surfaces and thin plate is at a distance of 0.8 centimeter from one of the plane surfaces, take the dynamic viscosity of glycerine. Dynamic viscosity mu is 8.1 into 10 raised to minus 1 Newton second per meter square. Now if you see here, you need to find the force that is required. So I need to calculate the value of F in two cases. In the first case, the plate is in the middle of the two plane surfaces, and in the second one, it is at a distance of 0.8 from any one of the two plane surfaces. So basically, I need to calculate the drag force F. Now, here if you see, this is my case 1. This is the first figure wherein I have the plate, the thin plate, exactly at the middle, which means this distance over here is 1.2 centimeter and 1.2 centimeter each. And we can now calculate. So if you see, I need to calculate the total force F on this plate. There will be a force acting from above. So you can say that here there will be a drag force. Say it is being pulled over here in this direction. So one drag force in this direction will be F1, which is a drag force between the upper surface of the plate and the glycerine above it. And there will be another drag force over here below, which is between this bottom surface and the fluid below. So this total force which is exerted on this plate will be F, which is equal to F1 plus F2, where F1 will indicate the drag force at the top surface of the plate and F2 will denote the drag force at the bottom surface of the plate. So now I need to calculate F. So for that we will first start with Newton's law of viscosity, which is tau is equal to mu du by dy. Now when you are talking about the first plate, and in that also when you are talking about F1, so I write this as tau 1 and this will be du by dy 1. Mu is constant. Now when I talk about this velocity, it is the difference between the speed of the plate and the du is the difference between du is the relative velocity between the thin plate and the upper large plane surface over here, as you can see. So this value will be 0.6 as it is given. For dy, you can see here this gap between the plane surface and the top layer of the plate is going to be 1.2 centimeter. So if I substitute here, this becomes 8.1 into 10 raised to minus 1 into 0.6 divided by dy, that is this gap. So it will be 1.2 into 10 raised to minus 2. So this gives you the value of tau, that is 40.5 Newton per meter square. So this becomes tau 1. Now, once you know the value of tau, we all know the formula of force. It is always shear stress, that is tau, into area. Now, area of the plate is constant. So, when you multiply this, it is 40.5 into area is 0.5. So, this becomes 20.25 Newton. So, that's the value of F1. Now, when I have to calculate the value of F2, if you observe carefully, you will write here tau 2 is equal to mu du by dy 2. Mu value is constant. When I calculate du2, that will also be zero point 0.6 because that is a relative velocity between the thin plate and the plane surface. Now in this case, dy is again remaining constant because this is 1.2 centimeter. So since it is same in both the cases, I can directly say that the value of tau 2 will again be 40.5 Newton per meter square. And the value of F2 will again be 20.25. So we can just write here similarly tau 2 will be 40.5 Newton per meter square and F2 will be 20.25 Newton. So the total force F will now be F1 plus F2 and the summation is 40.5 Newton. So that this is the value of the total drag force on the plate for case 1. Now let's talk about case 2. When I talk about case 2, between these two plate surfaces, you will have a gap of 2.4 centimeter and the plate is now placed at a gap of 0.8 centimeter from one end. So this gap will now be 1.6 centimeter. Now again we need to calculate F, which will be the summation of F1 plus F2. When I'm talking about tau 1, this will be mu du by dy 1. Mu is 0.81. Du, again, if you see, this will be the difference between the velocity of this plane surface and this plate. So it is again 0.6 because the plane surface is fixed. So this is 0 and this is 0.6. So the difference is 0.6 minus 0. And the gap for the first one, suppose if I say that this end is the first one, so this is going to be 0.8 into 10 raised to minus 2. So the value now turns out to be 60.72 Newton per meter square, and the value of F1 will be tau 1 into area. This area is 0.5. So F1 turns out to be 30.36 Newton. Now when I talk about the other end over here, so when I say tau 2 will be mu du by dy 2, this is 0.81 into, this is again 0.6 minus 0 and this distance is 1.6 into 10 raised to minus 2. So when you calculate this, you will get the value as 30.36 Newton per meter square and the value of F2 turns out to be 15.18 Newton. So the total value of F is the summation of F1 and F2 and the value is 45.54 Newton. So you can see here, if you place the plate at exact center, the value of force is 40.5 drag force, and when you place at a distance of zero point 0.8 from any one end, you will get the value of force as 45.54 Newton. Now let's take up the next numerical. A Newtonian fluid is filled in the clearance between a shaft and a concentric sleeve. The sleeve attains a speed of 50 centimeters per second. So the data given is the sleeve speed u, that is 50 centimeters per second, which is 0.5 meters per second. When a force of 40 Newton is applied to the sleeve parallel to the shaft. Value of force applied is 40 Newton. Determine the speed if a force of 200 Newton is required. So now you can see that this is equivalent to the first force, the speed value. If I have to calculate some value of speed u2, which is equivalent to another force F2, which is 200 Newton. So now let's solve this. You know the formula of tau is mu du by dy. Now when I talk about this velocity, it is always a difference between the two values, u2 minus u1, or rather I would say it's final minus initial. And initial has to be 0 only, then you can find that there is some resistance between the two surfaces. Otherwise, how would you generate a resistance if something is not fixed? So fixed means 0 velocity. So I can just say that this is nothing but mu into u minus 0. And this value I can just write as y. So this becomes mu u upon y. That is my tau. Now tau in itself is nothing but force upon area. So it is equal to mu into u upon y. So if you observe this carefully, this becomes therefore force is equal to mu into area upon y into u. Now why am I writing it this way? The reason is I want to derive a relation between force and velocity. If you observe these three quantities for a particular fluid, the value of mu will be constant. The area between the two shaft and sleeve area will be constant. The value of y is also going to be constant. So if everything is constant, we can say that by using mathematics, force will be directly proportional to the speed. Or I can also say F1 upon U1 is equal to F2 by U2. I know the value of F1 is 40, U1 is 0.5, F2 is 200, U2 is unknown. So I can find the value of U2 now as 250 centimeters per second, or it is 2.5 meters per second. So that is the answer for U2. Let's take another numerical. A 15 centimeter diameter vertical cylinder rotates concentrically inside another cylinder of diameter 15.1 centimeter. So there is one cylinder outside and one cylinder inside. Now the diameter of the outer one is 15.1 and for the inner one it is 15. So say this diameter is D and this is D1. So I'll write down the data. This inner diameter D is 15 centimeter, that is 0.15 meter, and the outer one is 15.010 centimeter. So this becomes 0.151 meter. Both cylinders are 25 centimeter high. So what is given here is the length, that is 25 centimeter, which is also 0.25 meters. The space between the cylinders is filled with a liquid whose viscosity is unknown. So there is a liquid between these two whose mu value is not known. If a torque of 12 Newton meter, so torque is T, is required to rotate the inner cylinder, that is this cylinder, you want to rotate this at 100 rpm. So speed is given. Determine the viscosity of the fluid. You need to find the value of mu. Now we will start with the formula for tangential velocity of cylinder. We know u is equal to pi d n by 60. We are aware of this formula. So I can just write here this is pi. The value of d is 0.15. We are talking about the inner one. N is 100 and this is 60. So u turns out to be 0.7854 meters per second. Now if I talk about the surface area of the cylinder A, we know it is pi dl. It's a simple geometrical formula. So it is pi 0.15, L is 0.25. So this is 0.1178 meters square. So we have figured out U and A. Now why did we do that? Because we are going to ultimately use the formula of tau, which is mu du by dy. Now if you talk about this formula, we don't know mu, we don't know the value of tau. So we can just write this as mu into the value of du. Now we know du by now is u minus 0. So this is 0.7854. And when we talk about dy, it is again the distance between the two cylindrical area. This is my dy, this gap. So dy is very simply d1 minus d. So this is 15.1 minus 15. So this turns out to be zero point 0.1 centimeter, which is 0.1 into 10 raised to minus 2 meters. Now since we are talking about a cylinder, this cannot be only like this is d entirely, right? So when I talk about the difference, we are giving this distance plus this distance. So this has to be half. The reason is we are measuring on only one side. So this becomes 0.0005 meter, because this will be the thickness, entire thickness, this much and this much together. But now we want only this distance, that is dy. So that's why I took half. Now when I solve this, this is 0.7854 upon 0.0005. This is the value of tau. We know that force is tau into area, and force in itself can also be written in the form of torque. Torque is always force into distance. Now distance will be half of this diameter. So when I talk about this diameter, it is d. So this will be d by 2. This is torque. So force becomes 2t by d. So let's substitute. Therefore 2t by d is equal to, in place of tau, I'll write this equation, mu into 0.7854 upon 0.0005 into area. Area also we have calculated 0.1178. So if you observe here, we know the value of d, we know the value of t as well. So if you substitute everything, you will find the value of mu. It turns out to be 0.864 Newton second per meter square. You can just substitute in the calculator and you'll get this value. So these are three more numericals that I wanted to add on this topic, and it is very essential to go through these numericals to have a better understanding of the formula of Newton's law of viscosity. So with this, I end the session. I hope you have understood the lecture. If you have any doubts regarding the numericals, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.